Hello world, good morning, good afternoon, good evening. Welcome back to CodingScientist.com. You are watching the most exciting series on Raspberry Pico. We are learning about MicroPython, how to code using MicroPython and put those code into Raspberry Pico to make things work. Either it can be IoT projects, it can be any of the electronics projects, or it can be a mini robotic projects. You can do ton loads of projects using Raspberry Pico and MicroPython. All right guys, let's take a look. So we are on lesson number 14, and in this lesson I am going to show you how to hook up two different DC motors and make it work. This is a very important series guys. This particular lesson especially is very important because hooking up a DC motor on Raspberry Pico is little bit tricky, and these things you'll use time and again when you are trying to build some kind of robot or any kind of moving objects and kind of thing. So basically I will show you how to control two DC motors with a motor driver module called L298N. For those of you who are from Arduino background, I am sure you would have used L298D chip or L298N driver module itself. So it may not be new to you, but for those folks who are absolutely beginners, just go ahead. I'll leave all the details below this video. You can go ahead and procure it from online. It just costs about 200 rupees, Indian rupees. It's very cheap throwaway price. So let's take a look at the circuit drawing, and it might look little complex, but if you take a look at it pretty carefully, it's very easy for you to understand. So you need two push buttons and two resistor, current limiting resistor, which is you can use 330 ohms or 47 ohms or even 100k. So that's not a problem at all. And you will need two DC motors, two any DC motors. I would prefer about 6 to 8 or 6 to 9 volt DC motors, or a general purpose yellow color BO motor, which is very commonly used. Just that costs about about 150 rupees or something. You can just go ahead and buy that, get one of those, and this is how you are going to basically hook the circuit. So basically, I am connecting the IN1 pin, the input pin of L298N, with the GP0 pin of Raspberry Pico. So again, once again guys, let me reiterate, you will have to refer to the pin drawing architecture. This is very important. Do not get confused. Do not go with the physical pin number, what is mentioned as 1 2 3 4 5 20, and from 21 to 40. Do not go by that. You need to refer to the green elements, the green square checker boxes, right, which is mentioned as GP0 is connected to your physical pin 1, and GP1 is connected to physical pin 2, and so on and on and on. And if you look at the last two, GP14 is connected to physical pin 19 and GP15 is connected to physical pin 20. So same way, all the green pins are meant for general purpose input output, GPIO pins. Those are the pins we will be accessing to do ton loads of projects, right? Of course we will be using rest of the pins as well as we get along into more advanced stuff. So when I refer to IN1 as GP0, that means what? So which is GP0 as per the architecture? The GP0 is physical pin 1, right? So that is what it is. You got to just correlate and try to plug it correctly, and then connect IN2 pin of L298N with GP1 pin. So if you take a look at your once you get your L298N here from the market, you can see the pins are marked actually IN1, IN2, IN3 and IN4. It's written actually all these four pins from where the wiring is going through. So it's very easy for you to understand and plug it directly into that, right? So and then the next, connect the IN3 pin to L298N with GP2 pin of Pico. And then now what you need to do, IN4 pin, which is again it's an input pin of L298N with GP3 pin of Pico. And then you connect the ground pin as per the circuit. If you look at the circuit drawing, the ground pin of L298N with the ground pin of Pico, and then make that as a common connection. So you'll have to pull out two different wires from the ground pin of that L298N. So you have to just unscrew it and insert two different wires into the same slot and screw it bit tight, or else it might be a little loose, because one pin will be connected to Pico and one will be to your battery. And then you need to connect a push button as shown in the circuit drawing. There are two push buttons. So basically, we will be controlling the motors using the push buttons, and you can use any value current limiting resistor, anything above 1k. It can be 10k, it can be 47k, it can be 330 ohms. That I would suggest 330 ohms for a safer side. And I have used 8650 batteries, which I am going to show you now. So these are the extra batteries required to power your motor. Remember guys, the Pico cannot drive the motor directly, only connected to your USB port to the computer. The current is not sufficient, so you will have to give an additional supply to your Pico through the battery to drive the motors. So that is how it works. Now basically the logic of this particular project is, when I press one button, the motor will rotate clockwise, and when I release that button, the motor will stop, and when I press another button, will rotate counterclockwise. So that is how this particular functionality is. As we go forward into robotics application, these kind of buttons we may not be using. This is just a trial test how our MicroPython code should work, and how to hook up the circuit, so that you guys get hands-on and practically getting exposed. But as we go forward, we will unplug these buttons, and we are going to connect transmitters to the similar kind of circuit diagram. We'll be remotely operating these motors. So I will show you one at a time. Alright guys, enough of my explanation. Let's get into Thorny IDE. Before that, let me show you the way I have hooked it up, so that you will get an idea. So this is my circuit, the main, all the connections with two different buttons here, two different resistors, and all the hookups. And this is the L298N board, which I mentioned about. And I used a very normal general motors just for testing purpose. This may not be sufficient for if you are trying to build some heavy duty bots, but this is good enough for prototyping and building a small size robot and try to learn and get hands on into the coding and electronics aspects. And this is the battery. Basically I'm using a 12 volt. It's actually 11.2 or kind of thing. 3.7 volt is one battery into 3, so it comes to little bit less than 12 volt. So you can go ahead and use this. All right, now let's do some coding aspects guys. So let me open up my Thorny IDE, so that you will have an idea what we need to do. So basically we need to declare couple of variables, of course. So let's take a look. Why is my IDE showing so small? It should, yes, it should be fine now. I hope you guys can see it large enough. Right, there you go. Now let's take a look. So first we need to import machine, right? In the last previous several lessons I showed you what I explained to you what is a machine. So from machine we need to import pin. The P should be in uppercase, and then from time we are importing sleep. All right, from time import sleep, and then let's declare our variables, like for example the IN1 from L298 motor driver. The pin goes to the pin goes to 0 comma pin dot out, like that. Okay, we are connected to pin 0 of Pico. And then the next one, IN2 equals to the next variable, pin 1 is connected to what? Sorry, the IN2 is connected to pin number 1 and pin dot out, like that. Pin dot out. and then we need to in3, we need to declare our in3 in uppercase. In3 equals pin, and that is connected to pin number 2, and we will say pin dot out should be in uppercase always. And then the in4, another variable as in4 is pin number 3. We connected to pin number 3, pin dot out like this. And then we need to declare our buttons. We have 2 buttons, so we will say button 1 equals to pin 16 is where we connected, and that is where we will give a input. So as we press the button, the Pico should take the input from the button and trigger the next action, right? So we need to say pin dot in for input, and then button 2 equals pin number 17, and what we need to say pin dot in again, that is for the second motor. Okay, now we have our variables declared. Now what we need to do, we need to write the logic. So let's put this into our loop. While true, oops, my keyboard strokes are weird sometimes. While true, now what is going to be true? If button 1 is pressed, if button let's say button 2 dot value, let me just scroll it down. Okay, button dot value equals to 1, that means on. If the button is pushed on, it takes as 1, right? What we need to do, what the motor is expected to do, then the trigger has to go through the IN1 of L298. What IN1 should be high, like this. It should be lowercase, high. HAGH, okay, I need to correct my English, high. And then IN2 dot, what's happening to my keyboard today, IN2 dot low, like this. Okay, close that function, close that parenthesis, and then IN3 again, it should be high because we are releasing the button. And then IN4 dot low, like this. And then what we need to do, we need to come out of that if and declare else. If the button is high low of button number 2, if that doesn't happen, else you do this. That is the logic of the MicroPython, what we are trying to achieve here. So let's say else, let me use elif loop. Elif button 2 dot value equals to equal 1, then what we need to do, the IN1 should go to low, okay, like this. And then IN2 should go high, like this. And then IN3 dot low, and then IN4 dot high. Scroll it down. And then what we need to do, once we define this particular logic, and then we have to come back to another elif. We need to declare this twice. Elif, let me leave a space. Elif button 1 dot value is nothing. It's not neither a 1, maybe it can be a 0. Okay, if it is 0, then what we need to do, then we need to say in1 dot low, everything should be low, in2 dot low, and then in3 dot low, and then in4 dot low. All right, I hope you guys are understanding the logic, guys. It's simple, right? You press the button, the motor rotates clockwise. Release it, it stops. Then second button you press clockwise. Then again release, stop. Both the buttons you press, both will rotate. That's the kind of logic we are trying to write here. So try to understand the flow. And then elif, again elif button 2 dot value, button 2 dot value, button 2 dot value equals 0. Then what should happen? Then in1 should trigger to let's see, the previous one was button 1, now button 2. Okay, all right. in1 is low. Yeah, it makes sense. in2, I think it's getting confused, guys. Yeah, let's try. I think it should work. in2 dot low, and then in3 dot low. Oops, what's happening to my keyboard? And in4 dot low, like this. Okay, what else? I think this should be good enough. Let's give a try. I hope it should work. Let's try to go through the logic again. So basically, from machine we are importing pin, and from time importing sleep, and in1. Okay, there are I think let's look at the circuit drawing once again to make sure the pins are perfect. in1 is GP0, in2 is GP1, in3 is GP2, in4 is GP3. All right, and the button is GP16, GP17. Okay, this seems to be okay to me. 0, 1, 2, 3, 16 and 17. 16 and 17. Let's reconfirm this. 16 and 17 and 0, 1, 2, 3. Okay, and 0, 1, 2, 3. I think it should work, guys. Let's hope for the best. All right, now what we need to do, when you run the program, this is not going to run as it is, right? You need to deploy this into your Pico microcontroller. So in one of the earlier lesson, what did I tell you? You need to save this program as main.py, main.py. So let me show you how. So you can go to either file, save as, save as, you can do that, or you can directly run. It's going to, once you click this run button, it's going to ask you the pop-up, you are going to get a pop-up message stating that you might want to save it in your local computer or in MicroPython Pico. So you need to select the second option, MicroPython Pico. I'm going to run this, and there you go. I'm going to save it. All right, now let's see, guys, if this works. I hope it works. Let me just switch over to my secondary video and then connect to the battery. So I am going to connect to the battery. Can you see it? I just have two jacks like this. So I'm connecting it like, and as soon as you connect it, you can see a happy little LED glowing inside. Alright, now let's press the button. I hope it works. Perfect. Alright, so the left motor is working. Right is not working. So maybe something wrong either with the circuit or with the code. Left is working but right is not working. So what is wrong? It could be some loose connection. Let me just try it. Maybe, can you see one motor seems to be working? Can you see it here, guys? One motor is perfectly working, but the second one is not working. So what should be the problem? Let's find out. Circuit, I don't see any loose connection. The resistors seem to be okay. Let's take a look at the code, guys. Maybe it should be a problem with the code, not sure, but there is nothing wrong. And or maybe, let's say 1 second, this wiring seems to be okay. I can see this seems to be working perfect. Then what can be the issue? ID says my machine is busy. I need to, okay, let me just control C to interrupt and then save this program again. What I'm trying to do is I'm trying to save it again into Pico. As main.py. Now let me try. Now both are not working. Control C. Alright guys, let me close the IDE and try to open the program again. Let me just copy this. Let me copy this entire code so that I don't miss it. Control A, Control C. I'm just trying to close the IDE. And then what we can do is we will probably have to disconnect the power, disconnect from the USB. Sometimes it happens, guys. See, these are some of the basic troubleshooting tactics, right? Now let me connect it again. Let me connect my Pico USB. All right. Now let me open Thani. All right. Thani is open. And okay, the device is busy or does not respond. Your options, Control C to interrupt. So can you see in the terminal at the bottom, guys? There's an error message. It says the system, I mean the Pico seems to be busy running that program still again inside. So you need to press Control C to interrupt. Alright, there you go. Now we disconnected file main.py line 36 in module. Alright, key interrupt. Okay, that's not an issue. Let me just put that code here again. Oh, okay, where did I save that file? Let me just check. Yeah, there you go. Why am I not able to save it? This is kind of weird. It's absolutely weird. Give me a second, guys. This is how it takes time to troubleshoot and stuff. But we will figure that out. Okay, there you go. I got my code. Pin number 16 and 17 seems to be fine. Import pin. Okay, import pin. Pin should be, P should be in uppercase. Now let me run this program. I will save this as main.py again. Okay, now it is saved. Now what we need to do, let me just connect to the battery and check if it is working. Let me connect to the battery. Alright, perfect. Now it seems to be working, guys. Let me just show you. Alright, now both the motors I am able to control. Can you see it? The left one and then the right one clockwise. I'll just keep the motor close by. And then the right button anti-clockwise and then clockwise, and both the motors together. Alright guys, I think it's a pretty lengthy lesson because we have to troubleshoot and debug in between. Either it's a, so this is an indication, guys, for you, for my viewers. Once you build the circuit and once you put your code, and if it doesn't work, right, there are a couple of possibilities. One, it can be a code issue, your MicroPython code issue, or it could be a circuit issue, or third option is it can be a battery, the power issue itself. Or the final, which is the least option, is your microcontroller itself is not functioning. You know, there are either the board is spoiled, or something else and kind of thing. Alright guys, that's the end of this lesson. I hope you enjoyed. Do stay tuned. I am going to come back with next lesson and we are going to get into more advanced stuffs using Raspberry Pi Pico with MicroPython. See you. Bye bye.